All right, guys, how's everybody doing today? Well, hopefully you're doing good. Today we have finally made it to quadratics, okay? So now we're talking about an equation where x is squared. What we're going to be looking at today is actually how does the value of a in f of x equals ax squared affect the graph of a parabola when a is a real number, okay? So we want to know how does a affect the graph of a parabola, which is what you get when you graph a quadratic function, is you get a U shape that we call a parabola. All right, so the first thing they want us to do is just look at the parent function for the group of quadratic functions, okay? So a parent function is just the simplest form for that type of a function. And in this case, the most basic quadratic function that there is, as you can read right here, it says the most basic quadratic function is f of x or y equals x squared. Okay, so that's the basic one, that's the parent function, and we can transform that function to get any other type of parabola. All right, so anyway, so they want us to just look at, well, what would the values of x and y be for a parabola? So you can see here there's a missing value of -2, and because -2 squared is a positive 4, then f of x or f of -2 would be equal to a 4. Okay. Well, what is -1 squared? Well, let's see. -1 squared would be -1 times -1, which would be a positive 1. So when x is a -1, y is a positive 1. So we could look at that as a point of -1 comma 1. This would be -2 comma 4. So these are points that the parabola will go through in the graph of it. Okay, 1 squared is 1, so you can see that when x is 1, y is 1. Well, when x is 2, 2 squared is 4, and 3 squared is 9. So you can see that the graph kind of has 2 for both -3 and 3. The y coordinates are the same, and that's why you get that curve shape, because it does not continue to decrease or increase forever and ever. It actually switches direction. It starts decreasing, and then once it hits the point 0, 0, it begins to increase. So you do have that point 0, 0 that the parabola will go through, -1, 1, -2, 4, -3, 9. And so for the first part of the parabola, you can see it's going to be decreasing. It's going to be going down as you look at it from left to right. But then at this point, which we call that point right there, the vertex, it switches directions. And you can see that, so when x is a positive 1, y would also be a positive 1, because 1 squared is 1, 2 squared is 4, 3 squared is 9. So you get those the curve going through those points there. So then you connect these points, and we get that basic parabola shape there. Okay? So you can read this here. The curve there is called a parabola. The point through which the parabola turns directions, that's the vertex. Here it occurs at 0, 0. It passes the vertical line test. If you remember the vertical line test, that means it is a vertical, scratch that last part. It says a vertical line that passes through the vertex and divides the parabola into two symmetrical halves is called the axis of symmetry. Very important there. So it does pass the vertical line test, so it is a function, but that's not what that was talking about. I read that wrong at the beginning. But anyway, so this y-axis in this case, that is the axis of symmetry. That is the vertical line that divides this into two equal halves, and that vertical line will always travel through the vertex. Now then, because the y-axis, x is always going to have a value of 0, then the actual equation of that line is x is equal to 0. So we could say here that the axis of symmetry for this parabola is x is equal to 0. All right, next, well, what is the domain? Well, the domain, if you look at the graph, you can see that the domain is going to be all real numbers because the graph goes to the left of the y-axis. Well, the left of the y-axis, that's where the x's are negative. It also goes to the right of the y-axis, and to the right of the y-axis, Well, that is where x's are going to have a value that is negative. So we are, excuse me, positive. So we can see that x's can also be positive. You can see, of course, it goes through the y-axis as well. That's where x is 0. So there's nowhere the graph can't go. So we can say that it is the domain is going to be all real numbers. X's are greater than negative infinity and less than positive infinity, which would be the same as saying all real numbers. Okay? And what about the range? Well, is the range all real numbers as well? And the answer to that is no, it is not. The reason why is because, well, the graph never goes where? Where does the graph never go? It never goes below the x-axis. It never goes below the x-axis. Well, any point that's below the x-axis is going to have a y-coordinate that is negative. So you get an x-coordinate, and no matter what, your y-coordinate is going to be negative for any point that is above the so x can be either positive or negative. It doesn't matter. If you're below the x-axis, your y value is negative. Because the graph never goes there, then we want to say that y's will be greater than or equal to 0. Okay, so that's the basic parent function and some properties of it, along with some very important vocabulary. Okay, so the next thing that we'll look at here is how does the value of a in ax squared affect the graph of a parabola. Okay, so graphing ax squared when a is greater than 0, here is the first part. So this is on page, the next page, second page of this section. So when a is greater than 1, okay, when the value of a is greater than 1, what you're going to have is you're going to have a, what we would call a vertical stretch of that parent function. So recall the parent function is y equals x squared. In that parent function, the value of a, the value of, the value of a is equal to a 1 in the parent function. Well, if a is a value that's greater than 1, then you're going to get a parabola that is narrower than that parent function. Okay? Now, when a is a value that is between 0 and 1, then you're going to get a what we would refer to as a vertical compression of that parent function, and that would mean that the graph is going to get wider. The parabola is going to get wider than it is for the parent function. Okay? And in addition, when a is greater than 0, when a is a positive number, that means that the vertex is going to be a low point on the graph, and therefore it will be a minimum value. It will represent a minimum value of the function. Okay? That's what we would need to understand about a when a is positive. Okay, and so then we can look at a specific example and see that when a has a value of 2, then you would get a parabola that is a little bit narrower than the parent function. The parent function, again, when I say parent function, when we're talking about parabolas, we're talking about y equals x squared. That function goes to the points 1, 1, and negative 1, 1. Okay? You can actually determine what the value of a is going to be by counting how far up do you have to go when you go over 1 from the vertex. So for example, for this parabola, we can see that it's got a vertex at 0, 0. Okay? And in order to get to this point right here, I would have to go over 1 and up 2. Because I have to go up 2, that is in fact does mean that the value of a in this case would be a 2. If you had counted over 1 and up, say, 4, then that means that in that case, if we had a parabola that went through that point and that point, then that parabola would have a value of a that is equal to 4. And so the equation of that blue curve would be 4x squared. So however far you have to count up, that is actually what the value of a is when you count over 1. Okay, so you can kind of determine the value of a using that logic. All right, so then next we've got another function here that we can graph, that they would like us to graph. And what you would see is, because the value of a in this one is 1/2, so using just what I said, without having to complete the entire table, I can determine that the graph is going to still have that same vertex at 0, 0. Okay, as all these from this section do, they all have vertex at 0, 0. But being that my value of a is 1/2, then if I go over 1 and up 1/2, those are a couple points that the parabola would go to. And because of the symmetry, then we would know it'd go through that point there. And of course, it'd be a good idea to get more points, but I can at least get a rough sketch of this parabola by drawing a curve that goes through those 2 points. I don't know what happened to those 2 points, but I'll go ahead and put them back there. Okay, and then graph a curve that goes through those points, and that is a rough sketch of what that graph looks like. The domain and range of both of these, both A and B, is going to be all real numbers for the domain, which we can say means that it goes greater than -infinity, less than infinity. That is a way to write all real numbers. Okay? And it has a range of, well, because these graphs, both on part A and on part B here, because they all stay above the x-axis, and they also do go through the origin where y has a value of 0, then we would want to say that the range is y's that are greater than or equal to 0. Okay? Does a vertical stretch or compression, this is problem 3 down here, does it change the axis of symmetry here? And the answer to that is no, of course not. The axis of symmetry, you would see here, is still the y-axis, and as a matter of fact, they're all going to have in this section a axis of symmetry that is along the y-axis. All right, and then there are a couple practice problems there that you could go through. Now then, the next part is what happens, what was going to happen to the graph when it has a value that is negative, okay, when a is less than 0. Well, when a is less than 0, you're going to get a parabola that actually opens up downwards. So the graph of, if we was to compare the graph of -x squared to the graph of x squared, you would see that it would be a reflection across the x-axis. So y equals -x squared is a reflection across the x-axis of y equals x squared. Now then, when a is less than 0, that means, like I said, it's going to open downward. Now then, more specifically, when the absolute value of a is greater than 1, the parabola is going to get narrower. It's going to be, again, what we would look at as a vertical stretch. So in a graph, an example of that would be y equals -2x squared. So in that case, the absolute value of -2 is 2, and that is greater than 1, and so you would see a situation where the graph would be narrower than it is for the parent function. And then when the absolute value of a is between a number between 0 and 1, such as -1/2, then you're going to get a parabola that is wider than the parent function. Okay? All right, and so here's the couple examples that the book has here. And you can, of course, fill out the table, which would be a good idea there for part B. However, because I see that the value of a is a negative 1/2 there.